Welcome back to the hyperbolic coding chamber. We are back once again in the original chamber. So here we are. The room is less messy, as you'll notice. The Discord created a petition. We got about a couple 100,000 signatures, so I was forced to clean up the storage room, or else my channel would be claimed. Or actually, it being taken by the Discord wouldn't be the bad thing, because I trust the HCC. So here we are once again. We're back in the home continent, but what else is there to say? My brain is dead, so I don't think we're gonna have a good session. But some of our best sessions is when we've said that. I'm on like 5 hours of sleep, and I was up for like 16 hours before. But if there's anything I believe in, it's the HCC. So I put a poll in the Discord, and I asked for some spirit energy. So all across the globe, all across the globe, the HCC is spirit bombing. So I need your energy, and so I feel the energy pouring in. So I think the session is actually going to be one of our best sessions, but we don't have a ton of time, so we're probably going to do around 30 minutes. But yeah, so we have more things to do. I think we're going to start kicking back up to an hour a day soon, but the schedule at this point has gotten a little bit crazy. We're doing a bunch of stuff, so hopefully we can make it make sense. As you can see, my speech chip. I need a firmware upgrade on the speech patterns, but yeah, a lot of things to be done. Hopefully we can get them all done. But for somehow the schedule is amping up, and yeah. I almost bought a Switch Lite with Mega Man X collection. Now only the real ones truly know. Only the real ones truly know about Mega Man X, okay? I'm talking about X1, 2, 3, 4, 5. There's no 6. 7, 8. I don't think there's a 9. I think there is a 9. And 11. These are legendary games. I almost bought them. I didn't even know it was possible to play them all on one machine, but the temptation was so great. And I didn't. I worried that if I got it, it would pull me off track a little bit. And it's not that having fun is bad or anything. We're definitely not trying to go. Actually, maybe this is monk mode. I don't think so. But yeah, I just wanted to put more time into more stuff, and I felt like if I got it, I try to do the same amount of stuff every day. And now, since I kind of modulated how much dopamine can be extracted from my environment, I kind of have to do other stuff to stay like stimulated. But if I'd gotten the Switch plus the X collection, I'd have just done the minimum that I needed to do every day, and then not done more, which is not the worst thing in the world. A little goes a long way, but I had some plans for this year, and I want to make sure we get to them. But that's a whole other thing. So the real thing we need to get to is the LeetCode extension. The sessions have gotten sloppy. There's no point in doing, well, there is a point in doing it every day. If it's worth doing poorly, right? The real thing that we need to do is get that LeetCode Chrome extension going so that we can hide the failing test cases. And the reason this is because we need to stay out of autopilot. If we don't stay out of autopilot, then we're not going to get any better. And I realized the last 10 or so easy I've been staying out of autopilot. And the way you get better is literally by slowing down and thinking, right? You develop the model, and then later on you can use this decision tree, right? You can just, I forgot what it's called, but I think, don't quote me on this, but I think if we treat ourselves like an ML, like a neural network, right? I don't know if it's back propagation or if inference. I think inference is using, but I think there's a point with the back propagation that takes so long because we're updating so much of this the model, right? This part is slow, right? Right, training models takes forever. But after you train, right, inference, I think, is when you use the model. It's much faster, right? You can type something in the chat GPT, you get an answer back in like 2 or 3 seconds. And that's what we're trying to get. The problem is we're stuck in inference mode. We're just doing inference and we're not getting any better. when we need to be like taking time to update each node or edge or whatever they call it. So that is really the problem here, and I think hiding the failing tests will force us to have to think, because the last 10 easy we just haven't been thinking. And I'll just write something down and click run. I think if we continue at this rate, we're just going to plateau, because we're not going to get a chance to run something a million times. And also, I think it looks bad it's bad form to just like keep clicking. Not that running something multiple times is bad, but there's a way that I do it that's just like I'm not learning anything, and I feel like that's pretty bad. So we need to get that extension going, and then once we get that, it should be pretty small. I think you just need some permissions to access the stuff on the page, and then we can just... Actually, no, I think we'll just make a custom extension. And then, yeah, I think we should be good. Because we just probably need to find an element and change visibility to hidden. That being the case... Yeah, I think that would take us to the next level. I kind of wish we had done this from the beginning, because we would truly be a different breed right now. But a necessary evil. I think we also have a comment that I neglected to get to, which was a pretty dope comment. I don't know if we'll be able to do this comment any justice, but we'll try anyway. So we have a comment from Salim. I can't even read. Sali Akram Joy. Are you preparing for an interview? I'm currently not preparing for an interview, but they say the best time, or I think it's easier to prepare ahead of time. So I just like using LeetCode to train focus, and then the problems at this point have become kind of fun. And if we ever do need to do interviews, we're already prepared, which is kind of a good thing to be, especially during all the big tech layoffs. So not a bad place to be, but we're still only doing easy. So if we did get canned, we would still have to do a lot of prep, but we wouldn't get caught by simple problems, hopefully. And then we have, can you give us advice what data structure or algorithm should we learn first? Also, which order should we follow to solve LeetCode problems? I would say take this with a grain of salt, because there are god kings in competitive programming and regular LC who can probably give better advice, because they've done more problems. They've done the interview circuit more than I have. But I could just kind of say what works for me. I think when I tried to figure out what to learn first, I got overwhelmed. So it was actually easier for me to just start with the easiest problem. So I used to do LeetCode in the past. I tried a couple times, but I felt when I first tried it, I tried an easy problem and I couldn't even do it, and I got so frustrated. And I was like, this is easy. How I can't even, like, this feels insurmountable. So I just got so frustrated. But I started looking for even simpler easy ones, like just easy string problems, string array problems to get my footing in. That helped me keep with the habit. And then from there, I feel like once I got a bearing, it was easier to slowly kind of, do a topic based, kind of random walk and learn things. There's a lot of data structures we haven't learned yet, also algorithms, but actually, no, I don't think there's a ton of data structures we haven't learned yet. The one that we can't implement, yeah, I think we know them, actually. Actually, never mind. I don't know all the trees, all the different kinds of trees. But I don't think I think it's easier, at least it was easier for me to not try to figure out what to learn first, because then I fell into this trap where I was trying to figure out like the perfect thing to do first, and no path seemed perfect, so I just chose no path, and that was a mess. I feel like the best way that worked for me was like a random walk that let me feel like I was at least mildly competent. So it let me have some easy early wins, like with string and array problems. And I tried to just keep it super simple. And then after I did that for a while, we started doing mediums, because I was closer to interview prep. And then other things came up, and then we slowed down to do other stuff. But we're gonna start clocking back up to an hour because we're making good progress, and we're almost about halfway done with all the easy. So that would be pretty cool when we get there. And then also, which order should we follow to solve LeetCode problems? I would say choose the order that allows you to keep going. That's what worked for me, but yeah, I feel like it can be, I don't know. Maybe I'm trying to avoid my own trap. I feel like whenever I try to do that, figure out what to do first or the perfect order, if it's not perfect, then I just kind of shut down. So what ended up working was just, I think I set a timer. I think I said I would do like 15 minutes of LeetCode a day. And I think it was even shorter in the beginning. I think it was like 5 or 10 minutes. And then eventually that exposure to showing up kind of helped. And then we kind of kept going. But I would say that it probably depends, right? There's much better videos on this because I'm just a dude. I'm just a daily LeetCode guy. Sometimes people call me that. Which order should we follow to solve LeetCode problems? Oh, it depends. I think another point I remember hearing from experience, some small experience, if you have an interview coming up, you should probably do the grind 75, which is like a subset of problems that's been chosen to hopefully give a good breadth and depth kind of hybrid. And it's like 75 problems, and hopefully, I think the idea is that if you finish all of them, you should be able to kind of muddle through, hopefully get through an interview because they're really common. I think I remember getting a few problems exactly from the grind 75, which is just a curation of problems. But I know of other people who've also gotten problems from there too, since some of the problems can be really good. But if you aren't prepping for interviews, I think that's like the perfect time to be preparing for interviews, because then you can take your time. You're not cramming. You're not frustrated with the lack, like if there's a lack of progress, like I was. But yeah, I would say. Yeah, I would say find what works, and then hopefully it can keep going. But that's just kind of what I did. But enough of the yip yapping. I'm gonna shut my trap, and then I think we're just gonna do 30 minutes. So here we are, back on the LeetCode circuit. So I don't think we've done this problem yet, but it's called rearrange characters to make target string. You're given two 0-index strings, S and target. You can take some letters from S and rearrange them to form new strings. Return the maximum number of copies of target that can be formed by taking letters from S and rearranging them. Okay, so if we can rearrange them, then we can move characters anywhere, which means we just have to check that structurally S has enough characters to support. How many letters does S have the structure to support? So let's just make sure we're understanding. For the first copy of code, take the letters at index 4, 5, 6, and 7. Then we can take 17, 18, 19, and 20. So we only have one. We can make one, and then here we have an example of a bunch of A's, and the target is A, right? And the most that we can make is just A, right? So I think we can break this down to two cases, right? The case where target consists of only one letter. If it consists of only one letter, then the number of copies that can be created is going to be the occurrences divided by the length of the target. Now, if target is multi-character, if target is two cases, target is multi-car or single car. If it's a single character, right, like we said, single equal occurrences divided by target dot length floored, right? Now if we choose multi, right, presumably if there is a target with 4 letters, CODE, and we have a map of letters to occurrences, then the smallest number of the maximum number of copies of target that can be formed could be taken as the min occurrence of target's letters. For example, right, for CODE, right, we would have a mapping of C to 2, O to 2, D to 2, and E to 2. If we took the min, it would be 2. For example, another example is if we had multiple C's, O's, D's, and E's, we could only ever make at most the lowest number of characters given. We could only make as many copies as we have the least amount of elements for. I guess another way to put it, I think, is if we have to make bottles and caps, if we have to make a series of 10 bottles and we have 5 bottles and 2 caps, you have to take the min of 5 and 2 and you get 2, because you can only make 2 total bottles because you have 2 caps for the 5 bottles. I think to break this down, we would need access, we would need to create a map of string to number. From here we can do map.set letter to, if map has letter, right, then we're going to do map.get letter plus 1. Otherwise, we're going to set it to 1. Then we'll have that list of occurrences. So how many unique characters does it have? If target unique cars equal 1, right, then what we have to do, we can return map.get target sub 0, because all the characters in target would be the same. We should check if target can be empty. It can't. So we'll get the occurrences for that target letter. And since we have the occurrences for that target letter, what we can do is divide it by target.length, and then we'll floor it. Otherwise, we'll have something called min copies, which is going to start at infinity. We're going to say for const occurrence, actually, of map, right? If car, if the character, right, is part of that target set, right? So what we can do is we can say and in fact we only use this variable once, so we can just say target.set size. We'll say target set has car, right? Then we're gonna say min copies equals math.min of min copies and awk. So in this version, what we're doing is we're going over the map, right? What we need to do is go over all the characters within target. Now we don't have to check if it's in the target set because we're going over target letter. Here we can look up the occurrences, right? And I think this should also go as what we want. Wait. This is why we need to remove the what we're failing, because then we could have actually thought about these and generated more cases as to why. So what we're loading into the map would be 4 of C, O, D, and E. And our target is code. While we check if we take the minimum of every character. We take the minimum of every character, we're gonna get 4. Code. I can't see how the current approach can be modified to fix this, so maybe we should try a different approach. I mean, you could also do it in n squared. Okay, I think we can do a different approach. We could have still kept that though. We'll still keep setting up the map. We'll still keep setting up the map. We'll still keep setting up the map of letters to occurrences, but we're gonna say while the map dot size does not equal 0, right? We're gonna count copies, right? At the end, we'll return copies. We'll also have an early exit opportunity. And here we're gonna say for const letter of target, right? If map dot, if we get the letter for the occurrence for the letter, right, and it equals 0, we're just gonna return copies, right? It means we can't make any more copies. Right. Otherwise, it means, you know, the occurrences do exist, and so what we should do is say map dot get, or we'll say map dot set, or yeah, map dot set map dot get letter -1. We're going to decrement the occurrences, right? Then we're going to check again. If we do map dot get letter, right, and it equals 0, what we're going to do is say map dot delete. And so the case where map equals 0 can exist, right? So it can't exist. So if the map does not have the letter, right, then we have to return copies. If we make it all the way to the end while decrementing, we can say copies plus equal 1. I think this should be better suited. So if we run this on I love LeetCoding in our head, the map is created, right? Then we're gonna go over code, right? C does exist in the map. We're gonna decrease the occurrences. If it went to 0, we're gonna delete the key, right? ODE, we made it to the end. We're gonna do copies plus equals 1, and map.size still exists. So the two stopping cases are that there's no characters left in S, or the target, the letter which we're requesting from target, the letter we're requesting from the map does not have any occurrences remaining. I feel like the worst case time complexity of this is n squared time. Considering that S can be arbitrarily long. Oh no, S can only be up to 100, but if it wasn't, we'll say size, right? The map, if we had all unique characters, it would have if it had all unique characters, if the map had all unique characters, right, then our map would have n keys. If we iterated over all the characters in target, that would also be m operations. So maybe it's n by m, where n is the number of letters in S, and m is the number of letters in target, and then we'll have done said work. Yeah, I feel like that makes sense. Even though we're only going over the map size, so the map size at worst can be n, and the target at worst can be m. So I feel like this makes sense. Oh, I guess map can only have lowercase English letters, so it would just be 26 operations. You need to, yeah, that's why we're getting sloppy. 26 yeah, they can only at max have 26 keys. If we only have at max 26 keys, it means we're going to be doing a constant number of operations, which would mean that the time complexity would probably be bounded to 26 times the length of target. Because for each possibly unique character in the map, we'll do at most 26 operations times target length. Now be O of n, where target or n is the length of the target string. So here we have check if every row and column contains all numbers. N by n matrix is valid if every row and every n by n matrix is valid if every row and every column contains all the integers from 1 to n. Every row and every column. Given an n by n integer matrix, turn true if the matrix is valid. So every row and column must have every number between 1 to n inclusive. So the length of the row is 3, so we have 1, 2, 3. It looks like order doesn't matter. If that's the case, I think there's a math-based solution to this. If every number must contain the value from 1 to 3, then I think we can calculate what this value should be in constant time. Because technically, row value would be equal to the summation of the series from 1 going to n. Summation of series of 1 to n, and this can be solved with Gauss's formula. If that's the case, it seems like we can just do 1 2 3 1 2 3 1 2 3. So I would say maybe the answer is if we take the Gauss of row, right, times 3, that would give you all the values for the rows, and then we can do it again to get the same values for the columns. So maybe it's just the Gauss of row times 3 times 2. And I think Gauss's formula is n times. I think it's n times n plus 1 over 2. We'll rename this to g, and then we'll return g times 3, or g times n times 2. And I also is 1 times 3 would be 3 times the 2 would be 6. If you do 2 times 1 would be, okay. I think multiplication doesn't care about the order. Wait a second. We went too fast. We actually have to check. Oh, we can. Well, if we're gonna sum it ourselves, we might as well just iterate through it. Well, if we iterate through it, how do we know? Even if we iterated through it and counted, how do we know? So we need this anyway. So here we can go we do matrix dot length row plus plus. Even if we did this, I feel like the window is so small. Right, we can change this to column. Right, and here we're just going to be summing all the rows. Right, so we'll say there's probably a way you could do it both at the same time. And maybe that could be a cool thing to be useful in the future. So you can do n by n, the sum it. You can also avoid the summing with the set, but it doesn't matter. We'll say sum plus equal row sub, matrix sub row sub call. That would give us 0. We also want to do the column at the same time. If we want to do the column at the same time, maybe we can substitute the row for the column. So for example, if you want to do 2 here, we also want to grab this 1. So we're in row 0, right? But we're in column 1. We want to be in column 1. So if we swap them, we could be in column 1. We could be in row 1. No, right, it wouldn't be this. It would be 1, and then from here, we'd like to do we go to 2, this would be row 0, column 1. Now we want row 1, column 0. So I think we can just swap them, but I think we want to avoid the case if row does not equal call and call, if row does not equal call, right, then we also want to do sum plus equal matrix sub call sub row. For example, if we were here in this 1 spot, wait, no, we go boom, boom. Actually, never mind. I'm gonna do it like this. I think the matrix is always square, so we can leave matrix.length the same. We can do sum plus equal. We want to go column wise now. I think we can just swap call to be 0, right? Row is going to be 0. On the next iteration, row equals 0, and then we'll say sum plus equal matrix sub call. If matrix sub call, which would be 0, on the next iteration, we would have call equaling 1 again. We have call equaling 1. then it seems like we'd actually like to use call like this, so you could swap them. Our output is true, and the solution should not be true. So we did kind of rush this one. I think we can solve this one. We're out of time, so we're gonna stop there.